Welcome to today's chemistry lecture. Today we are going to study yield, its types, percentage purity, and some question from exercise. So our first concept is yield. Yield is to be considered as the final product that we got from ending the reaction. The quantity of the product obtained when a chemical reaction is performed is called actual yield. And the scientist said that actual yield is always less than the theoretical yield. Theoretical yield is that we assume that the reactant will convert into products. So always come out less than the actual yield. The theoretical yield is amount of product which we calculate assuming that all the reactant react according to the balanced chemical equation, and by using the comparison between actual yield and theoretical yield we can find the efficiency of the reaction. Percentage yield is calculated by applying the following formula, which is percentage yield is equal to actual yield divided by theoretical yield multiplied by 100. In this example, we will find the percentage yield by comparing the theoretical yield and the actual yield. So our example is a chemist react 50 gram of zinc with the excess of nitric acid to get 80.2 gram of ZnNO3 2. Calculate the theoretical yield and the percentage yield of this reaction. First of all, let's see the solution. In first step, we will write our balanced chemical equation, which is zinc plus 2HNO3 into ZnNO3 2 plus H2. So number of moles of Zn is 50 divided by 65.37, which is equal to 0.76 mole. Zinc nitrate amount is 80.2 gram. Now we will find the theoretical yield. According to balanced chemical equation, the 1 mole of zinc gives 1 mole of zinc nitrate. 0.6 mole of zinc gives 0.6 mole of zinc nitrate. Amount of zinc nitrate in grams will be 0.76 multiply 189.38, which will be equal to 143.92 gram. So our theoretical yield is 143.92 grams. Now we can easily find our percentage yield because we have already been taken the actual yield and the theoretical yield. By putting our values into our percentage formula, which is percentage yield is equal to actual yield divided by theoretical yield multiplied by 100. By putting values as per 80.2 divided by 143.92 multiply 100, which is equal to 55.7%. So our percentage yield is 55.7%. Here comes our next concept, which is percentage purity. Purity refers to the degree to which a substance is free from impurities. Percentage purity of compound indicates the amount of pure compound present in an impure sample. We can calculate percentage impurity by using following formula, which states that percentage purity is equal to mass of the pure sample divided by total mass of the impure sample multiplied by 100. So for finding the percentage purity, we will first find the pure sample and the total mass of impure sample. While having these two, we can easily find our percentage purity. Now, here is a sample example to find the percentage purity, which states that 12 gram sample of a pharmaceutical product was found to contain 11.57 gram of the active drug. Find out the percentage purity of the sample. First of all, let's see the solution, which is percentage purity is equal to mass of the pure drug which is we obtained, which is 11.57 gram, and the total mass of the sample, which is 12 gram multiplied by 100. By using this method, putting values in this formula, we can easily find our answer, which is 96.4%. So our percentage purity of the sample given to a pharmaceutical product is 96.4%. Now let's begin our exercise. First of all, we have multiple choice question. Choose and tick the correct answer for the given choice. First MCQ is volume occupied by 15 molecules of ammonia gas at RTP. You know very well how to calculate 15 moles of ammonia. By putting into the previously learned formula, we can easily get our answer, which is 360 decimeter cube. Our second MCQ is how many moles of natural gas CH4 will be present in a cylinder if its volume is 18 decimeter cube at RTP. You know very well how to calculate this by putting the values into the previously learned formula, which will give the answer of 0.75 mole. The third MCQ is what will be the molar concentration of potassium hydroxide solution if 2 gram of it are dissolved in 100 decimeter cube of solution. For finding the concentration, we will use the previously learned formula for the concentration of solution, putting values into it, that gives us the answer of 0.36 mole per decimeter cube. The fourth MCQ is what will be the mass of sodium chloride needed to make a 15 decimeter cube of its solution with the concentration of 0.7 gram per decimeter cube. We will use our previously learned formula. By putting values, we will get an answer of 10.5 gram. The fifth MCQ, find out the concentration of H2SO4 in mole per decimeter cube of its 10 centimeter cube. React with 20 centimeter cube of NaOH solution having concentration 0.1 mole decimeter cube. By using previously learned formula of mole per decimeter cube, we will put our information and get an answer of 0.1 mole per decimeter cube of answer. In the sixth MCQs, if the molar mass of a compound is 178 gram per mole and its empirical formula is C3H5O3, what is its molecular formula? By using our previous knowledge, we learned about the molecular formula. We can easily say that the answer is B, which is C6H10O6. The seventh MCQ, when the natural gas burns in the air, which component is the limiting reactant? Obviously, we all know when we burn the gas, we automatically burn the natural gas. When the natural gas will be finished, our reaction will be complete. So natural gas will be considered as the limiting reactant. MCQ number 8. If the actual yield of a compound is 0.198 gram while the theoretical field is 0.217 gram, What will the percentage yield? We learned in this lecture about the percentage yield. By using the percentage yield formula, putting the values, we will get an exact answer of 91.2%. Here our MCQs are finished. Now we'll move forward to our short answer questions. So our first short question is, what is the molar volume of a gas at RTP? We will turn on the page 17, where we clearly see in the second paragraph, which clearly tells it is the volume occupied by mole of all gases occupies a volume of 24 decimeter cube at RTP. This is called molar volume. Our second short question is, how does the concept of molar volume useful for us? In the first question's answer, the same paragraph, the last line, the concept of molar volume is useful because it enables us to calculate the number of moles or masses of the gases if we know their volume. Our third short question is, how does the molar volume relate to the Avogadro's law? So answer is, molar volume and Avogadro's law are directly connected to each other. Molar volume actually is the outcome of Avogadro's law. Because of Avogadro's law, 1 mole of any gas contains the same number of molecules, that is 0.62 multiply 10 की power 23. Therefore, 1 mole of any gas occupies the same volume of 24 decimeter cube at RTP. This fixed volume 24 decimeter cube is called molar volume. This is the concept which we had learned right below the heading of molar volume, which clearly satisfies this. Our fourth short question is, why two different compounds may show the same empirical formula? We had already learned it into the comparison of the empirical formula, where we learned that two different compounds can show the same empirical formula because the empirical formula only represents the simple whole number ratio of atoms in a compound, not the actual number of atoms present in a compound. For example, acetic acid and glucose also have the same empirical formula of CH2O. Our fifth short question is, why is the percentage yield is important? We had already learned in this lecture that percentage yield tells about the efficiency of a reaction. A higher percentage yield means the reaction produces more products with less waste. In the chemical industry, it also helps to decide whether a process is economical or profitable or not. Our sixth short question is, what is the concentration of a solution in mole decimeter cube if it contains 49 gram of sulfuric acid in 1 decimeter cube? It's a simple question in which we will use the formula of concentration in mole decimeter cube, which is equal to number of moles divided by volume in decimeter cube. By putting values in this formula, we can easily get our answer, which is 0.5 mole per decimeter cube. Here our short questions are finished and our lecture is complete.